Hello and welcome to API Security with a Pinch of Salt. My name is Chris Westfall and I'm joined today by two of our principal SEs, and we're going to talk about the use and role of JWTs in supporting API claims management. So we're going to dig a little bit deeper into some of the themes and technologies behind the scenes with APIs. And this actually was a topic that came from one of our listeners. So we're really excited to dig into this. We do take requests on these. So if you are watching this and you think of something you'd love to hear us dig into, or even if you want to join one of these in the future, please reach out and let us know what you want to hear in upcoming episodes. But with that, we've got Adam and Ron on the line here, and let's dig into the topic. Are you guys ready?
Let's do it.
Yeah.
All right. Well, let's just take it from the top and talk about what are JWTs or what are JWTs, and just kind of level set. For those that are new to this, what does that term mean? And let's start with the definition.
Sure. So a JWT is a JSON Web Token, and what that is really a standard for creating data to communicate between systems. And in that data, there are different things that you can include. You can include JSON formatted data or payload. You can include a header that can instruct or control different components of the JWT. And normally, you would also include a signature component that will help validate the JWT is valid.
Yeah, makes sense, and that's important because we're going to talk about how this is used in the context of security, right? And being able to sign that JWT and make sure that we're passing the valid JWT around and it's not being manipulated. It's going to be an important part of using JWTs in general. But
exactly,
Adam, maybe we can jump into how JWTs are used and how they are used for security and why it's important to be able to sign these and make sure that we're passing around a valid JWT and that they're not being manipulated.
Absolutely. So, once we're authenticated to an application, we don't want to have to continue that authentication process. We're provided then our JWT, our JWT token, that authorizes us to continue to use that application to send requests, receive data. That's the most common reason why JWTs are leveraged, what JWTs are used for. You can see this a lot with a single sign-on, where small overhead and just allows us to have that stateless interaction with this resource that we're accessing.
Yeah.
Now you can also include additional data inside of JWT. It can be used for information exchange, so a faster way just to send data between two parties that is signed and is transmitted securely but easily used for authorization in today's more modern applications.
Got it. So I'm thinking like you have an application, maybe it has multiple components, maybe even your bank, right? And you want to move around to different functions of that bank. You don't want to have to sign in each and every time. If you want to go check on your CD, or you want to go check on your loan status or something like that. Those are potentially different backend applications for that bank, and instead of having to re-authenticate, you're gonna or the bank has implemented JWT, so you don't have to do that. It's a convenience thing, probably for the user as well as for the for the app owner as well.
Yeah, absolutely. Easily implemented that way, and it's a very easy way to add authorization checks into the requests that the users are making. A big thing in API security is checking what a user is authorized to see, and if you limit the scope of your authorization tokens, your JWTs, then you're implementing security that way as well.
Awesome. Well, Ron, maybe you could talk a little bit about how JWTs are built. What are some options for building those, either with tools or by hand? And more importantly, what should and should not be included in a JWT, especially if you're thinking about security?
Yeah. So JWTs are generated usually by different libraries that you use in your implementation in your code, and those libraries will generate a string, just a string of characters separated with two dots in between, and that string is basically a base 64 encoded version of the three different parts that JWT is built off. So the first part is normally the header. In the header, what we normally see is two things. You would see the algorithm that the JWT signature implements, and you will see the type of JWT token. And this piece and actually the payload as well are in a JSON format, hence the name JSON Web Tokens. So the header will include those items, and then the payload would include the data that is being transmitted between the two systems. It could be, your mobile banking app and the bank's APIs. And in the payload, the app or the party that is sending the data should include only data that is crucial for the communication, and should never include any real sensitive data. And the reason for that is that JWTs, at least the header and the payload are very easily decoded, right? It's a simple base64 encoding that anyone can go ahead and decode, and then basically anyone who puts their hand on a token can read the payload data inside the token without any problem. So for your question about what should and shouldn't be included, you should include something that would identify the user and identify the resource that the user is trying to access, but not more than that, right? So nothing like any personal identifiable information should be included in the JWT.
So,
and then the last part.
Sorry, go ahead. So no account numbers, no PII, like phone numbers, socials, anything like that. You don't want to have that because it's, I guess, fairly easy to reverse engineer that.
Exactly. Yeah. And then the last part of the JWT is the signature part. The signature part includes hashed strings of the first two parts, the header and the payload, plus a secret string that is then going to be decoded by the server. When the server receives the JWT token, it will decode that last part of the signature using the secret, and once it's decoding that, it is able to compare it with the header and payload components that were sent as part of the JWT and verify whether the JWT was manipulated or not. So this is how JWT helps you maintain integrity of the claim that that JWT is trying to make on the server.
Got it. Makes sense. So we talk about claims. Adam, what are claims, or what are some examples of claims? How would this JWT be used to make claims?
Yeah, exactly. So claims represent a key part of your JWT and what is the data that's included in there. There's three classes of claims that a JWT can contain. There's obviously reserved claim names, there's public claims, and then there's also a private claim name. We'll talk a little bit about all three of those. So the first one being reserved. There's a set number of reserved claims that should be supported. It's not mandatory, but should be supported by any JWT implementation. Things like expiration. So that's one of the key things, is that the JWT expires over time. If somebody was to steal or capture your token, they could easily bypass authentication and get straight to requesting the resource with whatever permissions you had. And so you want to be able to expire that token after a set time period. Other things like issuers, the audience that it's intended for, principal, all these things identify the subject and the creator of these tokens, and are things that you want to test to make sure they're not being manipulated or changed. We had a recent customer where the issuer was being modified, and so being able to detect when those claims, when those attributes or parameters are being manipulated is a key part in protecting your tokens. On the public side, these are things that are more just they're out there in the standard RFCs, but are more open to including additional data. And this is where, like we talked about, tokens can also be used to exchange information. And so you can add that information into your claim, things that you're looking to exchange back and forth with the third party. And then if you have a custom implementation or your own implementation of a JWT token, you can include your own private claim parameters. Just make sure those don't collide with any of the known reserved or public names. But we see claims continuing to contain or to have more purpose inside JWTs as these become even more popular, and we're including additional security checks inside the payload for these attributes.
Okay, well, Ron, Adam touched on it just a little bit, but I'd love for you to dig into some examples of breaches or attacks that are JWT related. Can you give us some examples of things that are people should be aware of as far as vulnerabilities go when it comes to JWTs?
Yeah, definitely. So when you look at JWTs, what an attacker might try to do is break your signature mechanism or bypass it in some way. And if they manage to do that, they can basically authorize themselves to do almost any action in your system, account takeovers, access to any data, and so on. So some of the different ways people might try to do that is by manipulating, for example, in the header, the algorithm parameter. And manipulating the algorithm parameter, they can go with a weaker encryption, or they can even try to use none as the algorithm. And that was one of the most common vulnerabilities with JWTs. When you put in none, basically you're bypassing the signature mechanism. The server will not check your signature at all, and you can put anything you want in the JWT. So that's one of the most common vulnerabilities with JWTs. And then an example of a breach, I think OAuth had a very famous breach a few years ago, exactly using the same mechanism. So they protected themselves from the none algorithm, but they did it in a manner that was case sensitive. So anyone who used none algorithm, all lowercase, would not be able to break the JWT, but a researcher was able to break their JWT by just using a capital E with the rest of the character lowercase, and they were able to basically do full account takeovers through OAuth. Obviously, that was fixed very quickly, and it does not exist anymore. But that's a very famous breach of JWT tokens.
So pretty simple tweak with some pretty impactful results. But luckily, OAuth took care of that, and that's no longer an issue. But it sounds like there are still some concerns about manipulation, right? And maybe Adam, can you talk a little bit about how you might want to protect against JWT manipulation, making sure that attackers aren't trying to manipulate those JWTs and do something funky?
Yeah, absolutely. So it comes down to I guess there's really kind of two styles of attacks. The first one is if your JWT is compromised. Let's say somebody actually steals your valid token and is now going to access the system as you. This is often a case we refer to as like impossible travel. Rarely will that person who is, just stole your JWT going to be accessing then the application from your same IP range or even your same geolocation. And so being able to determine when, you see the same JWT but not coming from a different location is very important, right? So we need to be able to detect those types of, use cases and be able to handle that. And the next one is if somebody is maybe trying to change their scope, like Ron said, lower the security on the algorithm or modify any of those parameters inside your JWT, and being able to determine when that happens. And all that is done through machine learning, being able to profile what the legitimate traffic is, what the legitimate token should look like, knowing, the issuer is the same, and the algorithm is the same that we're using to encrypt that JWT. And there's also additional attacks, right? You could actually implement injection or cross-site script attacks inside those parameter values. So being able to look inside the payload and actually determine what is being sent in the JWT is also very important. And so it's not just simply looking for the right content in the request, but actually looking inside into the payload to seeing what's being sent is the granularity and the security that you need to get to.
Got it. And you mentioned big data, and obviously AI and ML come into play there too, being able to make sure that you have consistency in those parameters and that you don't have that manipulation. Like you mentioned, the use case with the geolocation, right? You're not going to expect the same token coming from, I don't know, Europe, right? If you're logging in from the US, seconds later, it's like I think I've heard of those being called velocity attacks and things like that. So that's something we can definitely look for. And I know that's core to, obviously core to what we do at Salt Security is being able to look at those sorts of consistencies to make sure that we're not seeing big deviations in parameters and payloads, and also looking, as you mentioned, looking for things like injection attacks to make sure that there isn't anything being passed in those that would be detrimental to the application.
Yeah.
Awesome. Well, I know this was kind of a quick run through the world of JWTs, and I think you've given us a good primer on this. So maybe this is a topic that we can dig into even further in the future. But I want to thank you both for coming on and shedding some light on the topic. And I want to thank our viewer for making the request, and hopefully this is a good coverage of that topic that you wanted to hear from us about. And we look forward to more requests from folks out there in the future. With that, I want to thank everybody for tuning in. Thanks for watching API Security with a Pinch of Salt, and we look forward to having another episode out to you here shortly.